Okay. I'll try to. I'll see if I can check it off. Otherwise, I'll get 5-3 on Friday. There was a quiz on Friday. It's on 5-3, which is on integrals, antiderivatives, and the fundamental theorem of calculus. Okay? Grace, you get that? When are we having the quiz? Friday. Okay. Yes, it's 5-4, the fundamental theorems in both sections. Okay, so that'll be on the first part of 5-4, not the second part. Okay, shh, guys. What is an integral?
The area under.
What kind of area? It's the signed area. So an integral, can it be negative? Yes. It is a signed area. Some of you might want to write that down, because I found out yesterday some of you still don't know that. Okay. If my area looks like this, who is that? You? I know. What is the sign of this area? What's the sign of it? S-I-G-N. It's less than 0, right? Okay, so an integral, okay, Grace? An integral represents the signed area. So if it's more if it comes out negative, then more of the curve is under the graph, under the y-axis, sorry. Okay, area is different. Area is how much space I'm going to paint in here. I still have to pay for the paint, even though it's negative. Okay, so I just want the area. So there's two different questions. If I ask you for an integral, you have to worry about the sign. If I ask you for the area, I still have to worry about the sign, but I have to make sure it's all positive. Okay, now, a Riemann sum is where we started in this chapter. I don't remember, it wasn't the first one, but one of them, yes, there's some with negatives. Okay, you guys, check. So Riemann sum is where we started. The goal at the very beginning was to find the area under this curve. And we said if the curve went below, the y values were negative. So in this case, my y coordinate would be negative, which is why that integral is going to be negative. This was a Riemann sum. We divided this up. We partitioned this. We made them all the same size bases. You don't have to be, but we did. And then we put an infinite number of rectangles with the same size base. And we filled it in, and we found that was the area under the curve by finding areas of rectangles. This is the base, and this is the height. Okay, girls. And then Riemann says, I don't want to write that limit with sigma. I don't want to write that every time. It's not fun to write. Yeah, that's called a sigma. And it adds up. This is what adds up all those areas. We'll do a lot more with that in BC Calc next year, not this year. But we didn't do an infinite number of rectangles. Be thankful we didn't, because it's tedious and it's a problem. Okay, girls? So he said, let me make up a symbol, because math was created. And math exists in nature, but these symbols were created. And he said, instead of writing all that, let's just write this little integral symbol, which means find the signed area from A to B under this curve. This is a definition. Okay? That's a definition right there. He just said, let me make up this symbol. There it is. And then Leibniz, Riemann, Newton, all about the same time, they did all these rectangles under there, and they got tired of them. They said, what am I going to do if I get a sine function? Or what am I going to do if I get e to the x? It's hard. Then it's hard. I can't do some simple things that we do. Okay, Casey? And so they noticed something interesting about this, and I could have given you a bunch of problems with answers for you to notice this, but they found out this is a theorem, and this is the fundamental theorem of calculus. You have to know that. It appears on the exam many, many, many times. Okay? So all you do is find the antiderivative of the function and evaluate it at the upper limit, and find the antiderivative of the function and evaluate it at the lower limit and subtract them. It should bother you. Why is an area equal to an antiderivative? Why is an antiderivative. It bothers me. Well, I'd have to, the proof would take a while, and it's hard. It's not an easy proof. So I'm very willing to do it, but I'd rather wait till after the exam to do it. Because then I'm not under time pressure. Right now I'm under time pressure to get through the material, get you prepared for the exam. How are you going to get prepared for the exam? Besides, no, not the proof. What's the derivative of e to the x? E to the x. I didn't prove that either.
So you take the antiderivative.
Okay, so you find your antiderivative. I mean, I can, but that takes away time from you guys. Yeah, I can do that. Okay, so this is, you guys, this is a theorem. Now, what did I say about being good today? We'll get through this. I know you're so squirrely today. Okay, so let's do this problem. Now, we have properties of integrals. Can I go ahead and distribute this? Can I write this as negative 1 to 3 of x cubed dx plus the integral from negative 1 to 3 of 1 dx? Why would I subtract them? The integral of f plus g is equal to the integral of f plus the integral of g. Those are properties of integrals.
That makes sense.
Well, it's distributive properties of integrals. This distributive property does not work with exponents over addition. The distributive property does not work all the time. It does here. That's an integral symbol, which you could consider it as an S, which means sum. This is the base. This is the base, and that's the height of my rectangle. No, that has a different meaning. Okay. Well, we're all going to do what somebody else has decided that we're going to do. We're not going to create new math. Okay, so all we have to do is find the antiderivative of x cubed, which is what? Now remember, this is what we're finding the antiderivative of. Okay, guys? This tells me find the antiderivative. It gets used up like a square root symbol gets used up. When you do the square root of 4, you don't say that's the square root of 2. You say that is 2. It gets used up. If you say 2 plus 3, you say that's 5. You don't go 5 plus. Plus sign's gone, right? Same thing here. When I take this little symbol here with the dx, this tells me what my variable is. I'm going to find the antiderivative of that. Find the antiderivative with respect to x. Nope. If there's no dx, it's wrong. You have to have a dx. That's the base of my rectangle. That's the height. Now, on the exam, if you forget to put the dx in, they won't mark it wrong. I might. Hey, guys. Shh. What? Guys, I can't hear him. What? If I just have that, that is an antiderivative. It's integral. It's just wrong. I need this. I need to know what the variable is, because if it's this, I can't do that.
What do you do when you take something from
Guys, what? They're in the same what? It just means antiderivative, but with respect to y, and I would treat x cubed as a constant then. That gets you into multivariable calculus. So right now, it's the base of the rectangle. It tells you with respect to. What if I took the derivative of y with respect to t? Remember that? Well, as t changes, y changes. This is the area. This is my base. That's my height. And I'm going to do that one as that, by the way. I'm going to do geometry because I can. So I'm going to answer one of the questions off your quiz. Okay, what's the antiderivative of x cubed? Stephen? What's the antiderivative of this? X to the 4th over 4. Okay, you guys should know this one because it's not hard. It means you're not doing your homework. Plus C. Okay, I hear you guys. You're doing your math, which is good.
Okay, isn't antiderivative that 1/4 x to the 4th?
Yes, it's the same thing.
No, he has x to the fourth on the denominator. No, I know. I have 1/4 times x to the fourth.
That's order of operations. He has it correct.
Wait, no, I win. He has a line like that. He said I'm right.
Well, what do you show me is
He has
right?
that in the denominator. I'm saying
What's this one? See why I need the x here? Because it tells me what variable that is. Derivative, guys. The derivative of what gives you 1? X plus c. Oh, it's a different constant, isn't it? So we call it k. Okay, you guys. So let's go ahead and do this. And we did a number of problems in the other class out of the homework that hasn't been done. So it's a different constant than c. Yes. So I can go C1, C2, C3. There's an infinite number. I would. But do I need the constant? Plus, oops, sorry, it's not plus, it's what? This is the first antiderivative evaluated at 3 minus, wait, minus what? 1 to the 4th over 4 plus c. What's going to happen to the c's? They're going to cancel out. Do I need them? I only need them if I don't have numbers here, because they're always going to cancel out. Let's do the next one. This is a different constant. Could be the same. No, oh yes, it was. Thank you. Negative 1, that's 3. Okay. Now we're going to put in 3, right? Plus k minus, and then we're going to substitute in a negative 1 plus k. What's going to happen to the k's? They're going to cancel. So I don't need those constants. When I have limits there, that's called a definite integral. You do have to know a little vocabulary. I do need it when I have an indefinite integral. This has a definite answer. Indefinite does not. Well, it does, but not the sense you're thinking. Okay, what's 3 to the 4th? Well, it's 3 squared times 3 squared. So it's, what's 9 times 9? So it's 81 fourths. Then it's going to be, now be careful, we had some arguments about this in the last class. Do I take the minus times the minus there, or do I raise that to the 4th power? Exponents first. Yeah, and if you don't write it with, if you get it right and you don't write it with the parentheses on the exam, we overlook it. We overlook it. Now, that's with the previous chief readers. That could change. Can always change. Okay, plus, and then what do I got over here? I've got a 3. 2 negatives make a. Okay, so what have I got for an answer? Stephen, what do I have for an answer? What do I have? Okay. Are you okay with that? I'm not sure about this first row. Yeah. I just put a plus a constant. And, hey guys, anytime you integrate, you should put a constant in. But what's going to happen to these constants? They're always going to cancel because it's going to be plus c and then it's going to be minus c.
So you don't really have to worry about it.
What? This k cancels with itself. Because it's this antiderivative evaluated at 3 with the k here minus the negative 1 in there plus k. And so that cancels. These guys cancel together, not with the c's.
They'll always cancel.
That's right. So you never have the constants on a definite integral. Could I have done this answer geometrically?
Probably.
Okay, so let's look at it. It's this integral right here. Okay, that's the line, y equals 1. and I'm going to find the area from negative 1 to positive 3. That answer is not 1. It's geometry. It's 4 times 1. That's why the answer over here was 4, not 1. Could I do it geometrically? Why not? I'd rather do it geometrically than algebraically if I can. But I can't do x cubed geometrically because it's a curve, unless I put an infinite number of rectangles in. No. Okay, ready? Well, that's what you're going to do in section 5.4. Find antiderivatives and evaluate them, yes. We are finding the signed area. Should we graph it?
Yeah. We
Okay.
gotta use the pretty print that we can
I'm in the classic mode. Let's graph it. And I'm sorry that this is not working very well, but no. No. Well, that's the problem. Okay. Okay. Nope. An integral is a signed area. Okay. Area is always positive. Signed area could be negative. An integral can be negative. Okay. Yes. What are we integrating? What's the function? X cubed plus 1. Now let's graph it. And the problem with graphing it and using the graph, I'm not sure that my cord went. Okay, you guys, is that I have to have the domain right. And it'd be nice to have the height right. Well, I know I want to go from negative 1 to 3, so I'm going to zoom it 4. There it is. That puts you in a decimal mode. And, okay, if I go down here, no, it's nice. If I have a multiple of 9.4, when I do a trace, I will get nice numbers. See? I get 0.2 on the x's, not the y's. No guarantees with the y's. 0.3. So it's zoom decimal is what it is. Okay, I want to find... And we have never seen snow. Do you get snow in Beijing? Yes, we have a guest here. And what's your name? Anybody here speak Chinese? Oh, okay. I speak as much Chinese as I do Arabic. Okay, you guys ready? They lied about the forecast again, but what can you say? Okay, you guys, do you remember how to do this on your calculator? You guys, it's not even Heart Week this week. That's next week. Not right now. Later. Hey, you guys, the video's real time. Let's continue. Yes. Okay. Okay, you guys, do you remember how to find the area? Second, calculate on the graph, because it's kind of cool to see this. It's 7. And where are we going to start? Negative 1. And we'll go to 3. And it shades it. Now, if you get my programs, the Riemann sum program will actually put in as many rectangles as you say. Don't put in 100. It'll take forever. Yes, that doesn't take long. Okay? So
How long ago? That makes zero sense.
let's integrate with the negative. So you guys don't necessarily believe me. Let's do the same thing. Okay, girls? Let's do second calculate, but let's go from -2, where the graph clearly goes underneath the x-axis. So second calculate, and we will do 7, -2. Well, you didn't need to. Should we do it to 0?
Yes.
Are they equal? Okay, so I'm going -2 to 0. Are they the same? It said answers are -2, but you know what I have to do? I have to clear my drawing first, because I won't clear it out if I don't do that. So I'm going to go -2 to 0.
Now I'm debating. Give me the old. Yeah.
Okay, there you guys go. Okay, maybe this helps. This integral is negative because there's more underneath that curve, underneath the x-axis, than above. Okay, Jack, do you got that?
Got it.
Do you want me to go to the main screen? Do you remember how to do it with FNINT? Area is not negative, but the integral is negative. That's right.
But the area is constant.
That's correct. Let's do one more. This lesson should not take this long. Okay. So we're going to quit. Okay, ready? Okay, guys. You want to come up and do this?
I mean, I showed you. Yeah, I'll do it on the chat.
It's math 9.
And then go from -1 to 3.
Whoa, you got to get the function in there.
Whoa, hold you. I got the pretty proof.
The pretty print is nice because it's what they want to see when they grade your free response. And it's we did -1, comma 3.
How do you do the other thing though?
And it's 24. How do you get the vars with the shortcuts? You go alpha and trace, and then you get the y1 and all that stuff there. Okay?
What?
You go alpha and trace. This is shortcuts to get those y values. If you go alpha y equals, that's your fractions. So we'll do all fractions for you as well.
Do alpha y?
Yeah.
Whoa.
But that's another day. Okay.
That's 1. That's 5.
Okay, let's do this one. Okay, ready? Zach, are you ready? Both of you. I was just going to say, I got 2 for the price of 1. Okay. Now, one of the reasons that you're having problems with this is some of you aren't listening. Now, we are going to actually find the area. Guys, Jack, I want the area here. Not the integral, but the area. The integral will help me find the area, but I have to worry about the sign. And partition just means divide it up. Okay, so let's do this. Let's do this example. Analytically means algebraically. What does this graph look like? Do you know?
It looks like a negative upside down. Plus 4. Yeah, we'll go 4.
Okay, very good.
Look at that.
Okay, this is 0. Where is this? Stephen, where is it? Why is it 2? Because 4 minus x squared is equal to 0, and so x is equal to 2. Okay, but I want to find the area, not the integral, from 0 to 3. It's supposed to be a triangle. Most likely on the exam, you'll use a calculator. Okay. Because this is the x-intercept. They borrowed them. This is y equals to 0 there. That's the x-intercept.
I kind of want to see it.
Okay. You won't get the pretty pictures, though. I thought I had mine in here. Oh, no, I left it in my backpack. Okay. If you integrate from 0 to 3, what's going to happen? What's going to happen if I integrate from 0 to 3? Will I get the area? No. I will get a signed area. I'll get the net effect. Okay, so I can't do that. You could do absolute value, but guess what? We don't know how to integrate absolute value. So what's wrong with this part of the graph? It's going to be negative. So why don't we integrate from 0 to 2 of 4 minus x squared dx, and then I'll integrate from 2 to 3. Now that answer will be a negative answer. How do you make it positive? I could have the value, but easier to put a negative sign in front. Okay, guess what? I'm going to pause my recording. I want you guys to try this. No. On the calculator, it's different. Well, it's not different, but it's easier. Then it's minus this answer here, whatever it is. What's the antiderivative of 4? 4x. What's the derivative of 4x? It's 4. It's the power rule. It's really 4x to the 0. So you add 1 and divide by 1. Remember the power rule? What's the integral of x to the n? X to the n plus 1 over n plus 1. There's one problem. Plus c, don't forget. There's a problem with that. N can't be what? Negative 1. You guys like to push numbers around. What can I say? Okay. Minus, then what's the antiderivative of x squared? X what? Cubed over 3. Evaluated at 2 and 3. You have to break it into parts because when you integrate from 0 to 3, this will make that plus and that'll be minus, and you won't get the right answer. You'll get 3. It's 23/3. If I'm remembering. Now, the next part isn't particularly hard, but it's bookkeeping. Yes. Oh, yeah, you can break it up into parts. It's still the same. It's still 4x. Yep, evaluated at 0 and 2. I did break it up that way. Did you guys get it? Do you need some help with the arithmetic? Three. Because, you guys, you haven't done it. Because, you guys, if I integrate from 0 to 2, that's a positive number. If I integrate from 2 to 3, that is a negative number. If I take a positive and a negative, that will not give me the area. It'll give me the signed area. I want the area. Let's do the green one first. Or, let's just do this. What's 4 times x? It's 4 times 3 minus 3 cubed over 3. Don't skip steps. Minus, and the reason why is you're going to mess up your sign, and then I'm going to do 4 times 2 minus 2 cubed over 3. I just want you to believe that that's a negative number. Is it? This is 12 minus what? 27 over 3 is 9. Minus, and then that's 8 minus 8/3. Right? Okay, so in the first one, that 12 minus 9 is? I'm just following through on my work. I'm showing you. Right now, I'm just going to deal with this. It's under the x-axis. You don't believe me, it's negative. This is 3 minus 8 plus 8/3. Is that a positive or negative number? This is negative 5. What's 8/3? 2 and how many thirds? No, 2/3. What's negative 5 and a positive 2 and 2/3? Yeah, negative what?
2 1/3.
How do you know? Add these back up, you get 5. Okay, That is a negative number underneath that axis. So we put a negative out in front because this is what the area is under that axis. The area under the axis is 2, a positive 2 and 1/3. Right? The integral is a negative number. Okay, and I could see from yesterday we didn't quite get that. I think maybe we're getting it today. Well, this is, I want to find the area. You got to read carefully. An integral, they say integral, then you have to take into account things are negative. Okay, so what's this going to be? 4 times what? Second, what's this going to be? 2. Do you want me to put the 0 in?
No.
Well, you got to be careful. Sometimes this is not 0, so it's minus 4 times 0, which in this case it is. Minus, and then it's what? 2 cubed over 3 minus 0 cubed over 3. So what's that going to give me? Can you do this in your head, Jack? What is this? Okay, so I get 8. What am I going to get here? Minus 8/3. Okay, this is, well, I don't know. I need denominators of 3. Do you want me to do it that way? Or do you want to do a mixed number? I don't know, I'm going to write it out. So it's 24 minus 8/3. That's 16, right? So that's 16/3 minus this negative number. So it's 16/3 plus 2 and 1/3. Want to change that to a improper fraction? That's 8/3, right? Oh, I said it was 23/3. I remembered it wrong. I guess I lied too. No, it's not. We made a mistake someplace. Oh, yes, we did.
How did we make
Oh,
this sheet? That's possible. This sheet might have been when
well, let's take our calculator and find out what it is. I think it's 23/3. I'm off by 1, and I'd have to go back and find it. But it happens. Told you it's bookkeeping. Okay. Yeah, I messed up something. Okay, so it's y equals.
I'm using my creative imagination on
Yeah, I got to quit, I guess. Y equals, and that was 4 minus x squared. Now, you guys, do you know how to do this easily? Now, I got to delete that. Okay, I'm going to pretend I don't have the new operating system. I want to do this and integrate from, oh, I got to be careful, though. If I don't put in the absolute value, I'm in trouble, aren't I? Okay, you guys, this is going to save you time on the exam. You press second and enter, and it lets me go back in and change that. Now, I want the absolute value of y1. Well, let's not put the absolute value of y1. Let's make that 0. Okay, you guys, if you don't put the absolute value in, you get 3. There it is. Let's put the absolute value in. So I'm going to go second, enter, and then I can go back in here and I can change that. Now, this is tricky. I have to use the insert key. You know where absolute value is? It's in math. You can always find everything in the catalog. It's under NUM, and it's the first one. And then I have to close the parentheses after the y1. So that's why I said it was a little tricky. Sometimes it's just easier to repeat it. 7.6 repeating. Put your phone away, please. And what is that? What's 23/3? We're going to go find my mistake in about 2 seconds. It's the same answer. So I'm off by a little bit. Where did I make that mistake, you guys?
Right there. I see it. You don't see how good.
Where is it? I know it's going to get 23/3. But we don't, I mean, you can worry about it if you want or not. But you have to put absolute value in it.
It could be a little bit of both. Maybe a smidge of green.
You're going to have to put absolute value in if you want to do the actual area
You did that in
of the function. Yes. The same thing. Now, we can look at those quizzes or we can do questions out of homework on 5-3. Okay.